All right, lesson 4. We're going to deal with parallel lines and proportional parts. Okay, the majority of the stuff we're going to be working on is going to be within triangles. So we'll deal with those proportional parts within triangles. Also use those proportional parts to figure out those parallel lines. Okay, so we kind of talked this the last lesson. Um, again, when I'm looking at it, if these B and C, those lines are parallel, then this section here and the entire section will be similar to this section and then that entire section. Okay, so that's what we're finding out from these triangle proportionality theorem. All right, so looking at this first shape, okay, I'm going to zoom in just a smidge so we can kind of work with it. But as I look at these sides here, I'm going to write them in. It says PS. This section here is, this section here is going to be 12.5. All right. SR, that smaller section, is going to equal 5. All right. And then the opposite side, we got 15 for that PT. And our job is to figure out TQ. Okay, we talked it before, and the great news for this one is it's going to work the exact same way. Okay, we can kind of figure out that left side, that right side, and go together. So again, I'm going to do kind of that left side over the right side. So I'll put left is going to be over the right, just so that way I know, I forgot to put an H there. That way I know which order I'm going to do it. I'm going to throw an X in there just so I can figure out and I can solve for X. All right. So as I put this together, I get 12.5 over the right side, the top. So it's going to be 12.5 over 15. And as I set that one up, I'm going to set it up equal to, again, left side. So 5 over, and I don't know what this bottom one is, but I do have an X. All right, so I'm going to do the cross multiplication. I got 12.5 times X, and that's going to equal that 5 times 15, which is 75. Divide both sides by that 12.5, which tells me X, or that length of TQ, is going to equal 6. Again, we're setting things up. It's going to be that exact same fraction, that same type of setup. All right, I'm looking at this shape here. Again, I've got the parallel lines. I've got a parallel line here. I've got a parallel line here. It's going to follow the exact same way. Okay, so I'm still going to look at these ones. I've got the length of 3. I'm going to do the top. I'll kind of say the top over the bottom, just so I know which way I'm going to go. TTOM. All right, so I'm going to say this stuff up here is the top, and this one over here is going to be the bottom. Just that way I know which way I'm putting it. So I've got 3 over X equals 8 over 12. Okay, we're going to cross multiply just like we've been doing before. I've got 8X equals 36. Divide both sides by 8. My value for X is going to equal 4.5. Again, those ratios are going to work out the exact same way. Okay. On to this proportionality theorem. Again, I'm going to stick with the exact same way. This is showing you the same thing that we just did before. I was showing you didn't have to do all those extra steps. But, all right, with example number 1, okay, I plugged my numbers in there. I've got my same fraction. I'm going to do 6 over 10. So I'm doing the top half of the triangle over the bottom half. Okay, I want to simplify this down into a nice, easy fraction for me to work at. Okay, simplified down, this will give me, if I divide it, I get 0.6 for my answer. Okay, looking at this side over here, it said DG is half the length. So instead of saying 1/2 x, I'm just going to say 0.5 x over 1x. Okay, if I'm dividing both of those, my x's are going to cancel out. And I get 0.5 divided by 1. 0.5 divided by 1 gives me 0.5. Are these two the exact same number? They are not the same number. So for example 1, no, DE is not parallel. Or sorry, DE is not parallel to GH. All right. All right, I'm going to look at this one. I've got this next shape, DEF. So this triangle here, it says DH equals 18, HE equals 36. Okay, DG is half of GF. So I'm going to say DG is 1/2 of X. This one's going to be X here. Okay, I'm going to go through and I'm going to kind of work this thing here. I'm going to say 18 over 36. 18 divided by 36 gives me 1 over 2. Okay, so it gives me 0.5 for my answer. That's going to be my scale factor. All right, my scale factor for this is going to be 1 over 2, so 1/2. So if I set this other one up, I get 1/2 x, or I can say 0.5 x over x. Okay, if I set it up like this, I've got 0.5 over 1x. These x's will cancel out. If I take 0.5 divided by 1, that's going to give me 1/2. Are these the exact same things? They most certainly are. Okay? So that one I've got is going to be the exact same thing. So that's going to be a definite yes. They are parallel. All right. Looking at this new part, this is the one new kind of like wrench that we're going to throw into the lesson. For this mid-segment, a mid-segment of a triangle is a segment that's going to have two endpoints that are the exact same on both sides. So if I got these parallel lines and I've got the midpoint here, what it's telling me with the midpoints, I got a midpoint here, I've got a midpoint here. Okay, that's going there, that's going there. They're equal side on both. The length of this parallel line is exactly half the length of the other, of the bottom line. Okay? That's the rule with the midpoint, mid-segment theorem. Okay? If that second parallel line is perfectly in the middle of the two side segments, then it will be exactly half the length of the bottom line. Okay? So I'm going to look at this one. I've got these sides here. Okay, this is telling me this one is going to be 82 degrees. And if this is 82 degrees, okay, it's going exactly in the midpoint, exactly in the midpoint. Fingers crossed, it also means that this one should be 82 degrees. Okay, again, because if they're exactly the midpoint, then this triangle here will be the exact same as this bigger triangle over here. All right, so I just kind of want to point that out as I was working through it. All right, so the length of DE, it is exactly the same length. So again, I'm just going to kind of simplify it down without these extra lines going on here. Oops, without that extra line. So I've got this line segment, this one, and this one. Okay, they're going through. If this length here is 15 because of the mid segment, DE, so this was AC over here, and then this was DE. Okay, because of that, if this is 15, this one has to be exactly half. So the length of DE in this case is going to be 15 divided by 2. So that'll give me 7.5. Okay. All right. So that was that one. I'm going to change colors so you can kind of see what I'm doing for this next one. All right. I've got another triangle here. I'm going to redraw it without these extra lines going around. Okay. So when I'm looking for the DB, I have got A, B, C. Okay. And then I had that F here, and then the E was here. This one was 9.2. Okay, looking at the shape, again, I just redrew it on there so that way I can kind of visually see what's going on. Again, D is going to be in the middle there. That's going to be that midpoint. If this is 9.2, AB is going to be twice as big because that's the halfway point. It's going to be twice as big. So the length of AB twice as big is going to be 18.4. So that'll be that whole entire length right there. Because these ones are midpoints, I can take that 18.4, divide it by 2, because I'm going to split it up into 2 perfect segments, and that will tell me that the length of DB is going to be 9.2. All right? And the very last thing I'm going to be looking at is going to be that FED, the measure of angle FED. So I'm looking at this angle right here. Okay? Excuse me. I have got 82 for the top of this. Okay, 82 is my top angle here. Based on those measurements, I know that this size and this side are the exact same because it's a midpoint. Using those exact same rules, I know that this side and this side are the exact same length. That tells me it's a parallelogram. Okay, it is a parallelogram, and if it is a parallelogram, that means that all the opposite angles are going to be exactly the same. So when we figured out that the top, like FAD, that angle was going to be 82, it also means that FED, because of that parallelogram, is going to be the exact same degree as well. Again, we have those opposite angles, and as long as they're opposite, they're going to match up that way. All right, same thing. I'm going to look at this brand new shape. All right, I'm working through it. It's telling me, this one is telling me that these are going to be the exact same lengths. Okay, it is going to be that midsection. So if it's a midsection, that means that This length and this length are going to be exactly the same. This one and this one will be the same. And these ones will be the same. Okay, I'm going to kind of highlight some things, hopefully that you noticed on the last one. Because it's going to be a half length, this length and this length and this length, they will all be the same. Yeah, that AB is going to be 2 of those same measures. So instead of being 5, it'll be that 5 times 2, or 5 plus 5. So the length of AB, that whole thing, is going to equal 10. Because again, it's going to be 2 of those. If I'm looking at FE, I'm going to work the exact same way. Okay, I've got this segment, I've got this segment, I've got this segment. They are all going to be the exact same length. Again, BC was that whole entire length. That was 18. But if I wanted to shorten it down, half of 18, that would mean that this one was 9, this one was 9, and this one would also be 9. So the length of FE on this one is going to equal 9. And the very last one, I've got AFE. Again, this angle, let me point to it right over here. That's what I'm trying to figure out. Again, if this one is 87, this one over here is going to be 87. They are parallel lines. We already figured that part out. We will have that parallel line will have a transversal going through it. So we will use the same rule of that alternate exterior angles. And that tells me that angle AFE is going to equal 87 degrees. Again, that alternate exterior angles, because of the parallel lines and the transversal, makes finding these angles a whole lot easier. All right, the very last part, it works the exact same way with more than just one parallel line. Okay, if they're parallel, the ratio between this part and this part will be the exact same as, let's say, this part, this AB to BC, will match up the same way as that EF to FG. Again, those corresponding parts from each end will all work the same. Okay. So as I look at this first one, I've got 3 parallel lines. It's going to measure the same way. It says I've got a frontage that measures the properties boundary that runs along the side of a particular feature, such as a street, lake, ocean, river. Find the ocean frontage for lot A to the nearest 1/10 of a yard. Okay, it's going to work the exact same way. I'm going to say this stuff here will be my top, and this stuff down here will be my bottom. Okay, I don't know how long the top of lot A is. I'll give it an X. But I know the bottom of it is 60 yards. I know the top of this one is 58, and the bottom of this one is 42. All right, so if I cross multiply, okay, I've got the cross multiplication. I'm going there. I've got 42x equals 58 times 60. That's 3480. I'm going to divide both those by 42, which gives me my final answer of x equals 82 point, and I'm going to put 857. However, it said to the nearest, oh, that's not a highlighter. Let me try it again. To the nearest 10th. That's what they want. So I can't leave it as 82857. I need to go to the nearest 10th. When I'm trying to figure out the nearest 10th, I look at the digit in this place and I try to figure out, does this 8 need to stay the same or does it round up? Because that's a 5 or bigger. My final answer is going to be 82.9 yards. All right, on to my next example. Same thing, exact same ratios, exact same way that we can figure it out. Again, I've got that 13 over 26 to 16 over x cross multiply. I get 13x equals 16 times 26. I get 416. Divide both sides by 13 to get it by itself. And the length of the distance between those city blocks between Larch and Maple is going to be 32. Again, as soon as you know how to set it up, it turns into cross multiplication, and you guys are crushing this stuff. All right, the very last part is if we can figure out that they are going to be parallel lines, then we can set them up equal to each other. All right. So if those parallel lines are going to cut off congruent segments on the transversal, okay, it's going to find that the line segments will be equal to each other or congruent to each other, or congruent and equal to each other. So again, I've got that 7x minus 2 over that 4x plus 3. It's going to be the exact same ratio. It's going to be that same 1-to-1 ratio, okay, if I were to work this way. So that part's not really going to make much of a difference. So when I have problems like this, I can skip this cross multiplying step because it's going to be the exact same. And I can just set it up as 7x minus 2 is going to equal 4x plus 3. I don't have to do this step here because this ratio is going to be 1-to-1. When you multiply anything times 1, it's the same. Okay? So I can do this, start subtraction or subtracting down, I'm going to minus 4x here, minus 4x. I get 3x equals, because I'm going to add 2 to both sides. So 3x equals 5, divide both sides by 3. My final answer is that x equals 5 over 3. And that's my final answer. Okay? Again, when they are going to be the exact same, I don't need to do the cross multiplication. I can just set them equal to each other and solve it. So this one, it's showing me, again, I've got the midpoint. They're going to be exactly the same. I can set it up as 2x plus 1 equals 3x minus 5. Because it's still that 1-to-1. I can subtract the 2x. This gives me an x. I'm going to add the 5 to this side. So again, minus 2x here, plus 5 here. My value for that one, x equals 6. Very last one I'm going to give to you. Again, I've got these symbols right here that show me they're exactly the same. If they're exactly the same, I don't need to worry about really anything else. I can set them equal to each other. That gives me 3x minus 7 equals x plus 5. Do my subtraction, I get 2x equals 12, x equals 6. Again, I'm going quick because I know you guys know how to do these parts. Same thing on this one, I get 9y minus 2 equals 6y plus 4. I'm going to subtract the 6y from both sides. That gives me 3y. I'm going to add 2 to both sides. That gives me 6. Divide both sides by 3. My answer for y is that y equals 2. Again, I know it's a lot of stuff that was going on, but that's how we're going to set that one up. The assignment, page 495, 10 through 26, even. All right. Have a great weekend.